Gosh, Pocket Ronnie made me enjoy eating triangles. So welcome back.
Okay, we're going to be talking about triangles today. We're going to be talking about different kinds of triangles, different types. And the first way we're going to describe triangles is by their sides. We can describe triangles by their sides or by their angles. So we're going to look at the different kinds of triangles by their sides. The first kind is equilateral. Equilateral. Lateral means sides. Equal sides. An equilateral triangle means that all sides are the same, and you show that by a mark to where every mark is the same. That is how you mark an equilateral triangle, meaning all sides are the same distance. The next kind of triangle we're going to talk about is isosceles. And an isosceles triangle, two sides are the same distance. Okay, let's say that this side and this side are the same distance. If this side and this side are the same distance, these angles are also the same distance. You can have an isosceles right triangle. If that angle is right, these two sides can be the same, in which case those two angles are also the same. The angles across from the equal sides are also equal. So isosceles, two sides are the same lengths. Okay, and another, talking about the sides, scalene triangle. In a scalene triangle, no sides are the same. It's always difficult for me to draw a scalene triangle. Maybe that. That almost looks like an isosceles. But let's just assume you mark it like this. No marks match. So this means that no sides are the same distance. Scalene. So when we talk about triangles with their sides, equilateral, all sides are the same length. Isosceles, two sides are the same length. Scalene, no sides are the same length. Alright, we can also talk about triangles according to their angles. So here, this is also called equiangular. An equilateral triangle also can be called equiangular, meaning all the angles are congruent. If all sides are congruent, all the angles are congruent. In an equiangular triangle, there's only one number that all these angles can be. In a triangle has 180 degrees. If they are all the same, divide that by 3. It means each one is going to be 60 degrees. 60, 60, 60. In an equiangular or equilateral triangle. So an equilateral is what you call it when it's by its sides. Equiangular is what you call it if you're talking about the angles. Another kind of triangle is acute. Remember what the word acute means? Less than 90 degrees. So in an acute triangle, it means all the angles are less than 90 degrees and they all add up to 180. Like, let's just say this was 60 degrees, that was 40 degrees, so this means this has to be 80 degrees. It's not drawn to scale. 60 plus 40 is 100, plus 80 is 180. All those angles are less than 90, so that is an acute triangle. Acute triangle means all angles are less than 90. You can also have a obtuse triangle. An obtuse triangle just means one angle is more than 90. Remember, obtuse means greater than 90, but less than 180. So obtuse, let's just say that one is 120 degrees. And this is, oh wait, that can't be that. 30 and 30. So there you go. I just drew an obtuse isosceles triangle. So you can have an obtuse isosceles triangle. That would be that. So obtuse triangle just means that one angle is greater than 90 degrees. You have one obtuse angle in the triangle. You can also have a right triangle. Right angle means 90 degrees, so in a right triangle, one angle will be 90 degrees. That's a right triangle. So there are 4 different kinds of triangles according to their angles: equiangular, acute, obtuse, right. And if you're talking about according to the sides, equilateral, isosceles, scalene. Alright, let's look at some of these problems. You need to read the directions carefully. In 10D1, it's asking you to describe the triangle according to its sides. And they have this picture. So according to its sides, these marks show that all the sides are congruent. All the sides have the same length. So therefore, it is considered to be an equilateral triangle because that's according to the sides. And the word lateral means sides. 10D2, describe the triangle according to its angles. Well, every angle is an acute angle, so therefore it is an acute triangle. 10D3 says describe the triangle according to its sides and its angles. So you're going to be giving it 2 names. Well, according to its sides, none of these marks match, so it means no sides are the same length. So according to the sides, it is a scalene triangle. According to its sides, scalene. No sides are the same length. According to its angles, if you look at it, this looks like an obtuse angle to me. Looks larger than 90. So since it has one obtuse angle, it would be considered an obtuse triangle. So you should have both of those answers for that one. In 10D4, it says to construct an isosceles obtuse triangle. Well, I did that above, but I can do another one. So it has to have an obtuse angle, so therefore that is an obtuse angle. And then I want these sides to be the same length, so I try to draw them the same length. And then I did the best that I could. This is my ideal world. So those lengths are the same, so that's my isosceles triangle. Also means these angles have to be congruent. Well, I'm going to decide what I want my obtuse angle to be. Let's just say that this angle is 110. Well, let's just make it even an easier number. Let's just say it's 100 degrees. Means that there's 80 degrees left split among these 2 angles. Means that has to be 40 degrees and that has to be 40 degrees. When you are constructing these triangles, make sure that all of your angles that you're picking add up to 180 degrees. I didn't use my protractor to draw it, so it's not exact. I was just eyeballing that to be 100 degrees. But that is an obtuse isosceles. Obtuse triangle because it has an obtuse angle. Isosceles because these 2 sides are the same length. Okay, another thing that they're going to talk about in this lesson is the length of the sides of a triangle. One thing that you will see is A plus B is greater than C. A, B, and C represents the lengths of the sides of your triangle. A and B will represent the 2 shortest sides, and C is the longest side. So in order to construct a triangle, your 2 shortest sides have to add up to be greater than the longest side. If this does not happen, you cannot build a triangle. So in 10B9, it says, can you have a triangle with the sides 10, 11, and 12? So you take your 2 shortest sides, which is 10 and 11, add those together, and that should be greater than 12. If it is not greater than 12, then you say no, you cannot construct that triangle. Turns out 10 plus 11 is 22. That is greater than 12. So then yes, you can construct a triangle with the sides of 10, 11, and 12. Okay, 21. My cameraman just corrected me. You're right. 21, not 22. 10 plus 11 is 21. Thank you for correcting my mistake. Okay, look at 10B number 10. Can you have a triangle with the sides of 6, 7, and 2? Remember, you're using this formula here. A plus B has to be greater than C, the 2 shortest sides. So you pick the 2 shortest sides. Just don't pick the 2 first numbers. Pick the shortest sides, 6 and 2. So 6 plus 2 has to be greater than 7 in order for it to be able to do a triangle. 6 plus 2 is 8. 8 is greater than 7, so yes, you can make this a triangle. So if the two shortest sides do not add up, let's just say we had 1, or let's just say we had 4, okay? 4, 7, and 2. Well, then you have the two shortest side, which is 4. 4 plus 2 is 6. 6 is not greater than 7, and so in this case, you would say no. So if your two shortest sides do not add up to be greater than the longest side, then no, you cannot make it a triangle. If they do add up to be larger than the largest side, then yes, it can be a triangle.